It's important to remember that the James Webb Space Telescope can only observe a limited number of nearby exoplanets. To take the next step, studying alien atmospheres in finer detail, astronomers are looking ahead to future giants like the Extremely Large Telescope, set to begin operations in 2028. This ground-based marvel is designed to peer deeper into the skies than anything built before, giving us sharper, more precise data about the worlds orbiting other stars and their potential to host life. Until then, Webb remains the most powerful eye we have in the search for distant worlds. Despite its limitations, it continues to deliver discoveries that challenge our assumptions and expand our understanding of what might exist beyond our solar system. But researchers are already planning the next generation of instruments, telescopes equipped with technology that can dim or block the blinding glare of stars, making the faint light from planets around them far easier to detect. Think of it like holding your hand over the sun to see the world around you more clearly. One of the most promising tools in development is the coronagraph, a device built directly into a telescope. By shaping and filtering incoming light, coronagraphs can block starlight while allowing the much dimmer glow of exoplanets to shine through. Another radical idea is the starshade, a massive, flower-shaped spacecraft that would fly tens of thousands of kilometers away from a telescope, perfectly aligned to block the star's light before it even enters the lens. If successful, it would reveal planets in unprecedented detail, especially those in the habitable zone where liquid water, and maybe life, could exist. Of course, these technologies demand astonishing levels of precision. A starshade, for instance, would need to maintain alignment with microscopic accuracy across vast stretches of space. Add to that the challenges of miniaturization, energy efficiency, and survival in the hostile environment of space, and the scale of the engineering effort becomes clear. Yet the rewards are almost unimaginable. With these innovations, we could one day detect biosignatures, molecular fingerprints of life. The presence of oxygen, methane, and water vapor in just the right balance could reveal active biological processes, hinting that another world might be alive. Future telescopes may go even further, combining adaptive optics with starlight blocking technology to correct for distortions and capture sharper images. This could allow scientists not just to detect exoplanets, but to map their surfaces, study their weather systems, and perhaps even glimpse alien landscapes. Each leap in telescope design brings us closer to answering a question as old as humanity itself. Are we alone? The discoveries waiting on these distant worlds could transform not only science, but the way we see ourselves in the cosmos. The truth may be closer than ever, and when it finally arrives, it could redefine our place in the universe. So what do you think? Are we on the edge of discovering life beyond Earth? Let me know in the comments. And if you enjoyed this journey, don't forget to like and subscribe. Until next time, keep looking up. The James Webb Space Telescope has captured something extraordinary, flashes of light that seem to shimmer like the glow of a distant city, located on a world just over 4 light-years away. These mysterious signals come from Proxima Centauri B, the closest known exoplanet to our solar system, and they have reignited the age-old question of whether intelligent life exists beyond Earth. Could these lights truly be evidence of an alien civilization? For centuries, people have dreamed of what life might look like beyond our fragile blue planet. Every new discovery has only fueled that imagination, but what the James Webb Telescope has observed is unlike anything before. While scanning Proxima B, it detected luminous patterns eerily similar to artificial light. To many researchers, this suggests more than geological activity or natural reflection. It raises the possibility of something engineered, something alive. NASA engineers have expressed astonishment, wondering how long these lights may have been shining, waiting for our technology to finally notice them. David Kipping, an astronomer at Columbia University, has pointed out that Proxima B is not a simple world. Unlike most rocky planets, which absorb sunlight and re-emit heat as predictable infrared radiation, this planet behaves differently. Its relationship with its host star creates unusual energy patterns that the James Webb's infrared sensitivity was able to detect. This ability to peer into the faintest glimmers of infrared light makes the telescope uniquely suited to the task. Most observatories struggle to capture such subtle emissions, but Webb's instruments can separate artificial light sources from the broad glow of stars. If these signals fall within narrow, precise frequency ranges, far narrower than anything produced naturally by starlight, it would be a compelling case for artificial illumination. Proxima B itself is a challenging world. Locked in orbit around its parent star, it endures harsh extremes of temperature. One hemisphere bakes in constant sunlight while the other remains in perpetual night. If the planet has little or no atmosphere, the difference between the two sides would be staggering, scorching heat on one side and freezing cold on the other. But if an atmosphere exists, it could redistribute heat, moderating the environment and potentially allowing for habitable regions. Understanding these temperature variations is one of the keys to learning whether life could survive there. The James Webb Telescope, orbiting Earth in a position that allows it to study Proxima B's 11.2-day cycle, is capable of tracking these changes in detail. By analyzing the way infrared light fluctuates as the planet moves through its orbit, scientists can infer not only whether it has an atmosphere but also its composition. The next crucial step will be to identify chemical signatures, oxygen, methane, and water vapor, all of which could indicate habitability. Though the telescope has some limitations, particularly in detecting free oxygen, it can still reveal critical elements such as carbon dioxide, methane, and even ozone. Each of these would provide a piece of the puzzle, offering clues about whether the planet's environment could support life as we know it. If the faint glimmers seen on the night side of Proxima B are indeed artificial, then they may represent something far greater than just habitable conditions. They could mark the presence of intelligent beings who have already shaped their world with light. The possibility alone has sent ripples of excitement through the scientific community. If true, this would be the first clear indication that we are not alone in the universe. It would mean that while humanity has been gazing into the night sky and wondering, another civilization has been shining back, perhaps for centuries, perhaps for millennia. As the James Webb Telescope continues its watch, astronomers will refine their data and push further in search of answers. The truth may take years to confirm, but one thing is undeniable. With every new observation, the boundary between science fiction and science fact grows thinner. Whether these mysterious lights are the signature of alien technology or a phenomenon yet to be explained, they bring us closer than ever to answering humanity's oldest question: are we alone?